OK, so a little bit more about Jasmine. We haven't yet talked about another really important concept that came up when we discussed unit testing, which is the idea of stubs and fixtures. And the terminology is a little different in Jasmine. They're called spies, and we'll see why in a moment. But the idea is the way you create a stub in JavaScript or in your Jasmine test is you basically are creating a spy method that replaces the real method that is a property of an object. It's only that last phrase that differentiates the way that we've been doing it in RSpec. So in RSpec, we were able to create stubs that do indeed shadow the method, even if the method already exists. And you could sort of do that on any method you wanted, right? That's part of Ruby's dynamic nature. Because of the way spies are implemented in the Jasmine framework, you want to spy on a method that is a property of an object. So for example, the movie pop-up object that we created, remember we're following the strategy of create one object that has a bunch of properties that encapsulate your data and your functions. So we would spy on a function called new that is one of the properties of the movie pop-up object. And you can see why this would work, right? Here's a reference to the object, and this thing is really just the object's property slot. We can essentially look at the old property on the object, save a copy of it, and temporarily replace the property value with this fake function, the stub that we're going to use. And just like with RSpec, we can say, when someone calls it, here's a value to return from it. We can also say and call through. So rather than returning a canned value, once you've spied on it, allow the call to proceed. And why would you use that? Well, remember the use of things like should in RSpec, right? We want to be able to monitor that something gets called, but without interfering with doing its regular job. So and call through would give you that ability. You could also say and call fake. This is a case where you actually have set up another function that you want to use to return a canned value or in general override some behavior at testing time. So again, this is sort of the JavaScript Jasmine version of a seam, right? We're not changing the real function that is the property moviepopup.new, but we can spy on it. We can return canned values in our tests, or we can call an alternate implementation of the function in our tests. And as we'll see, a use case for call fake is when we want to do some stubbing of the internet, just like we did when we did our service-oriented architecture example. So in our simple example, why is it that there's quotes around new but not around movie popup? Because movie popup is actually an object, right? This is just a variable whose value is the whole object, whereas new is the name of a property of that object. It's not a variable. It's actually a property slot. So you can think of it as movie popup is an actual hash. This is one of the key values that's in that hash. So what do you do once you've successfully spied on something? Well, you can examine the calls on it. And the most convenient mechanism Jasmine provides for this is called most recent call. It is an object that you can dereference on the spy. So now we set up our spy. We've done something that should have called this new function. And now we can look at the most recent call to the function as observed by the spy. And for example, ask whether the arguments that were passed to the function contained a particular string. Right? So the syntax is sort of not quite as concise and surgical as RSpec, but it's pretty close for being JavaScript. Another example is when you wanted to, if you could spy on the Ajax function. And for example, you might want to verify when the user triggers some action that is supposed to cause an Ajax request, does the Ajax handler generate the correct URL with which to call the server? Right? So one way to do that is you could spy on the Ajax function itself. You could look at the most recent call and ask whether the first argument's URL was equal to the thing that you expected it to be equal to. And as we'll see, this is a way that you can stub out calls to the server because, again, when you're running Jasmine tests, especially when you're testing Ajax actions, you don't want to actually call the real server every time you run your tests. Just like when we were testing our TMDB gem when we were discussing RSpec, you don't want to actually call the TMDB server when your test suites run. So we're actually using the same idea here. And in a moment, we'll actually compare them side by side. But what we're doing is we're stubbing out the place where the call would have occurred. And once the stub is called, we're verifying that when the stub got called, it would have got called with the right arguments. Right? So same strategy that we've already seen. What about fixtures? Well, in the world of RSpec and Rails, the goal of a fixture was it's to provide an environment with some objects that a function expects to sort of already be in place when it runs. Right? And on the server, because we were creating SaaS apps with Rails, the kind of thing that it expects to be in that environment usually is models. So when we talked about fixtures in the server world, we were talking about let's create some basic models that live in the database because the code that we are testing expects for them to be there. What's the equivalent concept in the JavaScript and Jasmine world? Well, JavaScript usually runs in the context of a particular document that's rendered in the browser. So we might expect that the JavaScript code expects certain HTML to be there that it's going to operate on. For example, even in our trivial thing where I had a checkbox that when you check the checkbox, it hides a certain element, the code that does that expects that element to be part of the page so that it can call the slide up or slide down handlers on it. So fixtures in the Jasmine world really are chunks of HTML that you pull in for each test case so that when the test case runs, it will find those pieces of the HTML environment that it would normally have expected. So here's an example of an HTML fixture. Right? And just like an active record fixture is just enough models for the code to run, here an HTML fixture is just enough HTML from your page that the function in JavaScript that you're testing will be able to run in the environment that it's familiar with. So for example, if we wanted to test whether the, we had this section where we wanted to test whether clicking on a link about a movie would cause the right movie link to be followed. I've actually included maybe a little more HTML than would have been necessary. I've included a complete table. It only has one row, but at least it's well formed, right? The nice thing about this fixture is that it's a standalone legal piece of HTML. Why is that important? Well, remember that when you're running Jasmine tests, they're running in a browser, right? There's a page that comes up that's showing the results of all your Jasmine tests passing. And again, I'd encourage you to watch the screencast about this. But the Jasmine has to run in the context of that page. So when fixtures are loaded, that's what they're being loaded into. So even though they only represent fragments of the real-life page that your app would generate, it's good if they're legal fragments, because you wouldn't want your JavaScript test to fail because the process of loading fixtures makes your page contain invalid HTML. There's a really nice procedure, by the way. It's a nice hack, I think. And if you read the fallacies and pitfalls for section 6.7 in the book, there's a pointer to a great blog article about how you can automatically generate these fixtures from your actual views. Right? And why is that important? Well, just as with any other kind of fixture or mocks or factories that you use in your tests, if your code evolves, the fixtures that go with your test might get out of date. In other words, I've got some HTML that at the time I created this fixture, this is what my view looked like. But since then, I've modified my view, and now my JavaScript test isn't operating on the same markup that the real app would generate. So the solution to that is you can actually automate a task using Rake, where you can run your app, you can cause it to generate its regular views by calling the real controller methods, and then the views get chopped up into fixtures that you can use in your Jasmine tests. How do you actually use the fixtures? In your Jasmine test, you say load fixtures. There's a directory where you can put all of your fixtures, and that's where to look for them. And it will load them into a special div whose ID is Jasmine fixtures that's on that same page that's displaying your test results, right? So remember, the kind of complicating factor here is we're using the browser both to run the JavaScript tests and the code associated with those tests, and to display the results of running the tests. So it's like the browser real estate has to be shared between those two tasks. And the way that it does that is it creates a div called Jasmine fixtures, and any fixtures that your tests use get loaded into there, and they automatically get deleted out of there after each test is run. So just like RSpec will automatically tear down your mocks and stubs between tests, Jasmine will tear down anything that you've put into the Jasmine fixtures div between tests. So that I mentioned that the stubbing that we're doing is actually exactly analogous between the JavaScript world and the service-oriented architecture world. And this picture tries to kind of compare those two things side by side. So on the bottom is what we originally did when we were talking about the TMDB gem and talking to a remote site, right? And what we said is when you're creating your test, since you don't want to hit the server every time, you have to make a decision about where you're going to stub the action. You can stub as close to the application as possible, and remember we said you can stub what's the search TMDB method going to do? It's going to call the model method. One possibility is we could use stub and return and stub out right here. So when the test runs, the path is really short, right? We don't even get as far as the Ruby HTTP library. If you wanted to also exercise the model code, you could instead stub out what happens in the Ruby library, and fake web gives you the opportunity to do that. So in this case, you do call the model method. It tries to call the Ruby HTTP library, but at that point, we turn it back, and we provide a canned value. The exact same argument can be applied when we're testing JavaScript. When we have a JavaScript function executing in the browser, like getMovieInfo, one possibility is, well, it's going to call AJAX in order to get information from the server. One thing we can do is stub right at that point. We can stub the AJAX function by creating a SPY, and we can use callFake to fake out what the spy is going to do. Now, what does the spy do in this case? And I'll show you an example of the code here, which kind of goes with the diagram. So here's an example of some Jasmine code showing this use of stubbing, which has a subtlety that I wanted to bring up here. So when we click on the movie link, before we try to do our test, we're going to load that movie row, the fixture, the HTML fragment that I showed, because the code is expecting to find it. And here's a test case that verifies that it calls the correct URL. So we're going to spy on the AJAX function. We're going to trigger the click handler, which we expect is going to cause the AJAX function to be called. And then we're going to examine the most recent call arguments and make sure that we got the right URL. OK, that's all stuff we've seen before. Now the question is, how do we test what happens when the server call succeeds? So here's that code. And this is a little more involved, and I want you to make sure that you understand why. Again, we're going to get some fixtures. We're going to spy on AJAX. But this time, instead of just looking at the response, we're going to call fake. And here's the function we're going to call. So when the AJAX function gets called, we're instead going to kind of redirect the call over to here. And we're going to we're going to get past the arguments that would have been given to the AJAX function. And we're going to set the success property. In other words, we're going to make the arguments look like what would have eventually happened if the server had sent the call back to us. This is an important subtlety because when you look at the stubbing diagram, we have to understand why couldn't we just do spy on AJAX and return the thing that we wanted, right? And if we look back at our stubbing here, remember what happens in real life when we call AJAX. Calling AJAX doesn't actually return something, right? Calling AJAX sets things up so that when something is returned, we can set up a function to receive it. So if we're trying to do a test and stubbing out the server, we've got to mimic that behavior. We can use call fake to say, when AJAX is called, we're going to call this other function that essentially does our callback for us. We're going to call the success function, right? Because what would happen if we were doing this in real life in a production environment and the AJAX call succeeded? Well, the result of succeeding is the success function you specified in your AJAX argument gets called. So we set up a fake function that will do that directly, right? And it's because that's how you draw this stub boundary here. AJAX itself doesn't actually return anything, so we had to simulate that behavior. A case that we haven't talked about in the lecture slides, but that you can read about in the book, is that you can actually go even deeper than that and stub at the XHR level. So you can allow the AJAX function to be called. It will eventually have to call the browser's internal XHR function, and you can use mocks to get intercepted at that level. At that point, all you'd really be doing is testing whether the AJAX function call was doing the thing that you expected. But again, just as with service-oriented architecture, there's differences in when you'd want to stub. Sometimes you want to stub close to the service. Sometimes you want to stub far away. But the thing I really want you to take away from the diagram is the strategy of how you think about testing when you need to isolate a piece of code, especially from a remote server, right? And in the service-oriented architecture, it arises when your service wants to talk to some other remote service. In JavaScript, it arises when your JavaScript code wants to talk to an AJAX controller action that lives on the server. All the same techniques apply, and the same mechanism using mock stubs and being able to examine the results of a stubbed call, all the same concepts transfer over. So that's really the high order bit of doing TDD for AJAX. So I'm kind of cheating because I sort of gave you the answer to this. But just to walk through, in the example, why did we have to use and call fake rather than just using and return? If this were to hypothetically appear on an exam, you might have choices such as we could have done it either way. AJAX doesn't actually return anything, which is the correct answer, as we explained. AJAX args is in the wrong scope. This is arguably true, but it's not the reason that it wouldn't work. Or that we needed to be able to spy on the AJAX call. Well, we already know how to spy on the AJAX call, so that's not the answer either. So I didn't really get to use this question because I ended up explaining it to you instead, but that's fine. The important thing here is to understand that whenever you're stubbing something out, the entire goal is to replicate the behavior that would have been done by the server, but without getting the server involved. And in the AJAX case, what that means is the behavior is you would have called the success function, just make a fake function that calls the success function directly. So that's a subtle piece of stuff, and this is something that the book does a much better job of describing in more detail with a bigger example.